Fridays. It's a super exciting one for us. We are joined today with David from Fuel Labs and our instructor, Tamara Ringas. David, do you want to give yourself an introduction?
Sure. Yeah, my name is David Mihal. I'm an engineer. I've been kind of working in the crypto space since 17, and yeah, now I'm kind of leading up product research and strategy at Fuel Labs, and I'm really excited to show you guys kind of some of the stuff we've been building today.
Cool. And Tam, I think for any newcomers.
Hey everyone, I'm Tamara Ringas. I'm a Solidity engineer at Alchemia, and I'm an instructor at Web3 Sanctuary in their Solidity courses.
Cool. Yeah, I think I'll be handing it over to David, and who has a super cool presentation to show everyone. I think it's going to be a really good one. Cool. And without further ado, David, I think over to you. I will share your screen and we can get
Sounds
right
good.
into it. Awesome.
Cool. So yeah, I'm going to talk to you guys a bit about what we're building here at Fuel and kind of how that plays into the larger Ethereum ecosystem and what Solidity developers might take from this. So I know this is um, a Solidity meetup, Solidity event. We're going to be talking a bit about a lot of it's going to be focused on the programming language that we're building at Fuel, which is called Sway. But I want to kind of like contrast that a bit against Solidity, kind of like what do smart contracts look like with Solidity? What do they look like with Sway? What are kind of the some of the benefits you can get from using this? And then I'm going to kind of like split the talk in half. First, we'll be doing a bit of this contrast of like looking at some Solidity code and looking at some of Fuel's Sway code. And then I also want to talk about something called predicates, which is one of the like I think really cool, interesting features that we're building with Fuel. It's something that got me really excited about Fuel and like what potential things we can build with this technology. And yeah, I would love to kind of share that with you guys. So before I jump into all the code stuff, I'll give a quick background on kind of what Fuel is and what we're aiming to do. So you can see kind of this big, like our big problem we're trying to solve here, which is that blockchains are really painful to use right now. I don't think this is like a very controversial take. If you've been in the space, or maybe especially if you haven't been in the space, you'll know that this is not. There's a big contrast between using Web3 products, which are often kind of clunky and confusing, and using Web2 products that we're all used to. You go to use blockchain applications, you kind of like deal with all this technical stuff. You see a lot of hexadecimal. The first thing you do when you get into like set up a wallet, you have to write down these words. Like there's just a lot of UX friction. What we're trying to solve, and um, there's a lot of developer like issues as well. Building in Web3 is really complicated because the space has kind of we're still in the very early days of the space. The technology has evolved a lot, and um, it can be quite complicated to kind of attach together lots of different technologies. One reason that this is still kind of so painful after all these years is that a lot of the spaces evolved very incrementally, right? Ethereum was created back in, I guess it launched in 2015. Solidity, the main programming language for Ethereum, launched around this time. And the space has progressed and changed so much, but it's happened kind of progressively, and we've made kind of these many incremental changes, which has made things a little bit messy. Every time there's like an update to Ethereum, it needs to be backwards compatible, right? There's already many applications built on Ethereum. There's almost 10 years of applications. We can't just go and break all these old applications. That would kind of violate these ideas of immutability. That's kind of such a core principle of blockchains. But that limits what we can do. So Ethereum, the EVM tends to evolve very conservatively, very slowly, and it tends to change by kind of adding new features on top, as opposed to making like radical changes. So we're at a space and time when I think we can. There's a big shift in the way blockchains are worked, the way blockchains are architected, and that makes a huge opportunity for a project like Fuel to kind of come in and like really shake things up and create kind of a new path for how to build blockchains. The primary like opportunity is this modular blockchain ecosystem. So this is rollups. I guess anyone in Ethereum is really familiar with all these rollups that are being spun up. This is like this has been kind of the direction that most of the Ethereum community has been building since I guess 2019, 2020. Been very rollup oriented, and we're really starting to see these rollups take hold. Arbitrum and Optimism are huge. We've seen some like amazing advancements in the technology from in the ZK rollup space. One thing that even with all the success of these rollups, they're mostly the technology has mostly just made a rollup that tries to look the same as Ethereum. It says, okay, we're going to get this increase in scalability. We're going to get fast confirmations, lower fees, but overall, it's just going to still feel like Ethereum, which is generally good for developers and users that are used to Ethereum, but it doesn't let us really bring the space forward too much. The other opportunity for Fuel is that a lot of that technology, that Optimism, Arbitrum, and the ZK teams like ZK Sync and stuff have been building is it's becoming mature and it's becoming commodified, which means we don't need to focus as much on like how do we build a rollup. We've kind of figured out how to build a rollup. We can start to think like, okay, if we can build any kind of rollup, and that's somewhat trivial actually, let's expand our mind about like what do these rollups actually look like. And that's kind of what we're trying to do at Fuel is we're building an ASIC-centric rollup, which is a bit different than the way most other blockchains are architected. So I wanted to kind of like explain what we mean by an ASIC-centric rollup. So I put together in Figma here this maybe presentation here for this. I'll just show this in Figma. I'm not a great designer, but what I tried to show here is what we call program-oriented design. This is kind of the architecture that Ethereum and the EVM use, and just like most blockchains in general use kind of a similar structure, because most blockchains are kind of derived from Ethereum. So we have all these programs, and most of the state of a blockchain lives within a program. Program is kind of the word I'm using for like smart contract, essentially. Every smart contract is like a program, and it's got some state in it. So there's a question.
No, sorry, go for it.
Oh,
No,
sorry. I can't see the screen, so feel free to jump in if there's any questions. So every smart contract is like a program in itself, and it stores the state of that program within that smart contract. So what I showed here is like we've got 3 people on Ethereum. We've got Peter, Sarah, John, and what I'm trying to show here is actually like how the state is stored in the chain itself. So Peter has some USDC. I guess in Peter's wallet, the only asset that's actually in his wallet is ETH. This is kind of how Ethereum works. Is the only asset that the Ethereum node really knows about is ETH. Everything else is implemented as a smart contract. So Peter's got 20 USDC. He's got looks like he's got 2 Bored Apes, big Bored Ape guy, and he's got an LP position in Uniswap before. But the interesting thing is like these assets are stored in the program itself. So Peter's USDC balance is inside of the USDC smart contract. His Bored Apes, those are in the Bored Ape smart contract, and his Uniswap position is within the Uniswap smart contract. The other reason I kind of gave these 3 examples is these are the main 3 asset types that we have on Ethereum, and I'd say just generally. There's fungible tokens, so USDC is an ERC20 token. NFTs are ERC 721, and we're starting to see more. I guess not everyone might be familiar, but there's this ERC 1155 token, which is the token you use when you basically want one smart contract to emit multiple tokens, but have them be potentially fungible or potentially non-fungible. This is a standard that's been around. Some NFTs have been using it, some gaming projects, but Uniswap before is also using it, and I think that's going to be bring a lot more prominence to that standard. But so the interesting thing here is like, if you look at these wallets, you go, okay, there's not anything in the wallet. Like Peter's tokens are not in his wallet; they're in a bunch of other programs. That's where they're stored, and these programs don't even like really. They're all different. These are 3 different kinds of programs, 3 different token standards that represents different kinds of assets. So we looked at that and we went, blockchains, the main thing blockchains do is manage assets. There's a million different types of like things that have been built with blockchains, but managing assets is kind of one common theme that they all tend to do. And if they're all doing that, like why does every developer need to write all the code for these assets every time? And why does the code need to look so different? Why can't we just have a blockchain that just knows what assets are? In the same way, like Ethereum knows what ETH is, it knows that asset, it just doesn't know any other assets. So this is kind of the other world, the asset-oriented world, which is what we're trying to build with Fuel, where you can see we still have all the same wallets, the same programs, but a lot of the state, a lot of these assets themselves have moved to the wallets themselves. So, the USDC basically just stores like a supply. Bored Ape contract doesn't store anything. I'll get to Uniswap in a second, but we can see that the assets themselves actually live in users' wallets. So now you go, okay, Peter's got some USDC, he's got some NFTs, got some LP positions. He still has the same ETH, that he had before, but it's all in his wallet. He has full control over these. Same with Sarah, same with John. Yeah, you can see with Uniswap, that's one other thing I didn't mention is if I say I put some USDC in Uniswap, in the same way that like Peter's USDC doesn't live in his wallet, it lives in the USDC smart contract. The USDC in Uniswap also lives in the USDC smart contract. So you can see Uniswap is like a user in this like table of balances in USDC. So we kind of see the same thing here. This USDC now lives within the Uniswap smart contract. The other thing that's probably worth mentioning is that's a bit of a difference is you might see that some of these assets are the same asset. So Peter's got 0.1 ETH and 0.7 ETH in the same wallet, even though they're the same asset. This is because in Fuel and say like in these asset-oriented paradigms in general, Fuel uses what's called the UTXO model. Anyone kind of familiar with how Bitcoin works will be familiar with the UTXO model, where your assets, they're a bit less like a row in a database, and they're a little bit more like a piece of like a paper piece of money. If I have $20 and I have $5, those are not the same. I can't combine those into a $25 bill. They're still separate things. So we can talk more about how those UTXOs work. That at a high level is kind of the two different ways that like blockchains can handle assets. So to jump into some code, I wanted to kind of show what does this look like? How do we handle assets in Solidity, and how do we handle assets in Sway with this asset-oriented paradigm? So the first thing I put here is just a really basic ERC20 token. So again, anyone who's made an ERC20 token will be familiar with this. We've got, the key part here is this balance. This is where it's a mapping where everybody's assets are stored. We've got transfer function, which is going to just adjust decrease one person's balance, increase another person's balance. Bit of logic there. There's the whole transfer from system where you have allowances. I'll say this is something that transfer from kind of always it's something that bothers me, because this is why you get this like approval transaction you have to send before you send a real transaction on Ethereum. And yeah, I tried to put together like the bare minimum code you needed to have like an asset that'll work everywhere in crypto. You need to be able to transfer tokens. You need this like approve and transfer from. And I also added just a mint and burn function. Everything here is totally permissionless. This would not be a very good, valuable token because people can mint as many as they want, but you can mint a token and you can use it kind of anywhere on any like Ethereum or EVM chain. So now let's look at like doing the same thing, like a very minimal token in Sway. I guess I should mention Sway is a new programming language that we built with Fuel, and it's a programming language for smart contracts, just like Solidity. But we tried to kind of say like, what would a really modern language for smart contracts look like? And so it's a bit of like a baby between Rust and Solidity. The syntax looks a lot like Rust. So anyone who's comes from the Rust world will probably think this looks familiar. But we tried to keep. We also wanted it to feel like Solidity. So I'll say we removed some of the like memory ownership features that give Rust a little bit of like a learning curve. And we tried to make it kind of feel as easy to build with as Solidity, but as like modern and structured as Rust. So anyways, here's that same token that we built in Solidity before, and now we're building it in Sway. And you see this is super short. This is like, actual lines of code. It's like, there's like two functions. and each function has one line of code. Because as I was saying before, in Fuel, assets are native to the blockchain itself. You don't need to write the logic for an asset. The blockchain will handle it. All you need to do is say like, hey, I want to mint a token, and I'm going to send it to the sender. Or if they want to burn a token, then they're going to receive a token and say, hey, we're going to burn it. We don't even have any logic to like check what asset they sent, because it'll fail if they sent a different token other than the same token. So that's a very simple token there. And so next I'll go to a bit of a fuller ERC20 token. So this will probably be not too different than that last one we looked at. We're basically adding like the metadata of an ERC20 token. Every ERC20 token has a name, it has symbol, decimals. I think that's the main difference. We also have a supply for tracking the total amount of token that exists. Again, this is like I copied the soulmate template ERC20, so most of this is the same. Yeah, I think it's all the same, other than whenever we mint and burn a token, we're going to increase the supply or decrease the supply. So now let's see what a bit of a fuller token looks like in Fuel and Sway. So we're going to do the same thing we did before, but we're just going to track like a little bit of metadata. So you can see kind of we have a lot these same functions we're used to, supply and name and symbol and stuff, but they have this match function, or this match statement, I guess is what it's called. What this is doing is in Fuel and in Sway, every contract can mint like an arbitrary number of tokens. Basically, like tokens on Fuel are more similar to ERC 1155 tokens. That was like that this Uniswap v4 type token where you can have different types of tokens. Everything in Fuel is like that. So if we want to get the supply of a token, we have to say like, which token are we getting the supply of? Because this contract only makes one token, we're going to check like, okay, is that the token that the one token we mint? If it is, we'll give the supply. We'll read that supply from storage. If not, we're going to return none. This like optional some none thing, that's a common like Rust pattern to return, basically like null or an actual value. So we have to kind of like check these functions. They all can like query any asset. So we check, is this an asset we've created? If it is, we return our metadata. So I'll call this simple token with symbol simp, I guess. And 9 decimals, but other than that, it's still pretty simple. It's still pretty straightforward. So let's go to the next type of asset. That is a ERC 721 asset. Again, this should be familiar to anyone who's ever made an NFT before. But the way NFTs work, especially the way the ERC 721 standard works, is there's actually 2 different mappings. So every NFT has a ID, which is a number. And we have one mapping that says for every NFT, who owns it? You go address to, token ID to address. We also are counting how many NFTs does that account own. So that's the balance of. A lot of people have said, this balance of function is probably kind of unnecessary. I'm not sure how many smart contracts actually query this balance of function. And because it is like a bit of state, it makes NFTs a lot more expensive than they probably need to be. But it's part of the standard. This is kind of one thing I was like hinting to earlier of like Ethereum has evolved very incrementally. So, it wasn't created with like fungible tokens or non-fungible tokens in mind. It was just created this general purpose machine. And it was, I think, when CryptoKitties came out that the team behind CryptoKitties came up with the ERC 721 standard, added balance of, and now that's kind of how NFTs work in Ethereum. But other than that, we have a lot of the same functionality that you have in ERC20. So there's this like approval mechanism. There's, I guess, 2 different approvals. You can approve all, you can approve individual tokens. Basically, methods of approving that a smart contract can hold your tokens. So if you want to deposit an NFT into a smart contract, you need to approve it. Just the same way you need to approve a fungible token. So again, a lot of code here to do transfers, to do safe transfers, which lets you include some data. Just a lot of boilerplate here. So this is something that can be a big barrier to entry if you're a new developer. You just want to make an NFT, right? You heard this like NFT craze. Maybe you heard that artists can make money off of NFTs. It just can be kind of you have to go through there. We can now look at what an NFT looks like for Fuel.
Wow, it's tiny.
It's basically the same as it's almost the same as the fungible token. What we're doing here, I guess the main
it's
difference.
Just an asset.
It's just an asset. So this is what's really cool is like Fuel assets are just assets. The main thing that's different is like this mint function. So if I'm minting an NFT, we're basically going to get the number of NFTs that exist. We're going to, that'll be the ID of this NFT. We're going to increment that number. And then we're going to mint, we're going to basically mint a token with a supply of one. And that's what an NFT is. It's an asset that there's only one. You can't split it. We're also going to store that ID in like a mapping, like this way equivalent of a mapping. And then we use that mapping for all these other, the metadata things to see if there's, for the name, for the symbol, we'll just basically check if this is like an NFT that we minted as a contract. And if it is, we'll return it. The supply of every token, it's a one, basically either a one or a none because they're NFTs. So that's the NFT on Fuel. It's a pretty short piece of code here, pretty simple. And okay, we've got one more token type to go through, and that's, as alluded to before, this ERC 1155. So this is the one that's, I guess, most similar to Sway because an ERC 1155 contract can mint arbitrary amounts of tokens, and they're all kind of fungible by default, but you can make them non-fungible by just, again, minting the token. It's a little bit more lightweight because you only have balance of. There's no like, basically you only need to store one value for every token balance in an account. You don't need to store two like ERC 721 does. This is one reason like a bunch of NFT projects have used ERC 1155, even if they don't need this like semi-fungible like multi-token functionality. A lot of projects use it just because it's just cheaper. It doesn't need to store as much data.
Yes, it's much more lightweight.
Yeah, exactly. It's like it should be basically half the cost to like transfer and to mint compared to ERC 721. But aside from that, we see a lot of the same logic. We've got you're transferring a token, you change the balances. There's a bit of there's this kind of like I guess ERC 721 and ERC 1155 have these kind of like optional call hooks. So this is, I guess, kind of adds some functionality that would actually be nice to have in ERC 20, which is the ability to like transfer a token and call like a function on the recipient smart contract. Like if I'm sending an NFT to a smart contract, I can have that smart contract like receive it and execute some logic. It's a little bit like messy the way they have to do it. Like I have to like kind of dig into to understand what this logic here is doing. But that's part of ERC 1155 and ERC 721. We've got like a few different functions. Safe transfer from, there's like batch transfers, balance of batch, like just a lot of boilerplate here to do really simple stuff. Let's see, how many lines of code is this? Oh, it doesn't show me, but a lot of lines of code here. And I think everyone can guess kind of what we're going to look at next is we're going to look at like basically the same Sway smart contract we've been looking at the whole time, which is, just being able to mint any arbitrary assets. And, this one, we're just kind of setting the balance of each token and returning this metadata. So the cool thing about, I guess there's a number of cool things about having these like native assets and having it all look the same. One is, we don't have to juggle like 3 different token standards. You don't need to build specific smart contracts and specific applications for specific things. If one example would be there's a project on Fuel that's building an order book exchange. So, what is an order book exchange? It's just you create an order, say, hey, I want to give 1,600 USDC, and I want to get 1 ETH. I'm saying what I'm willing to give and what I'm willing to get. But since on Fuel, all assets are just assets, this is also basically an NFT exchange. So you could use this, like this could replace Coinbase, but could also replace like OpenSea. I could say I want to trade ETH for USDC, but I could also say I want to trade a CryptoPunk for USDC, something like that. So yeah, I think the goal here is just to really lower this barrier for developers to build these assets, because again, that's something people are doing all the time. So next, I wanted to show kind of we've looked at how to like make assets, what do assets look like from the outside, but I want to show like what's it like to be a smart contract that uses assets and consumes it. And I thought we would look at the ERC 4626. That's not an ERC I've memorized. The ERC 4626 standard. If anyone's not familiar with the standard, it's actually a really cool standard. It's like a vault standard. So the idea of this standard is that you can basically, like, so much of DeFi is these like derivative tokens, right? You deposit your DAI into Compound and you get C DAI, or you deposit into Aave and you get A DAI, and then you take these and you put them into Uniswap and you get like an LP token, or you can put things into Yearn and you can get a token for that. Even some farming, like yield farming smart contracts, it's like you deposit a token into the smart contract and you get an NFT that represents the asset you deposited, but also any yield that you've farmed. So it's such a standard pattern, but most smart contracts kind of implement this totally differently. So 4626 came along. It came along probably a little too late to be widely adopted, but there's definitely a number of like newer protocols that are using it. So it basically standardizes this pattern of like a smart contract where you can deposit an asset and you deposit an asset and you get like this wrapper token, and then you can kind of burn that wrapper share and get the underlying asset. So I'll do a quick walkthrough, because I guess this is probably a standard people might not be as familiar with. So for the deposit function, we I guess the logic for this contract is this is one vault which has one underlying asset, and the vault itself is an ERC20 token. So you basically, when you deposit an asset, you get a share back to represent like a claim on that underlying. So this asset, this is the address of like the underlying asset. And you would deposit it, basically say, I want to deposit this many assets, and this is the address that you should mint these shares to. It'll calculate the number of shares. The way share calculation works is like at the very beginning, shares and underlying will be 1-to-1. So if this is let's imagine this is like a lending market like Compound. So if I deposit 10 DAI, if I'm the first person to deposit, I'll get like 10 C DAI, whatever. But over time, of course, like if it's in a Compound, it'll accrue interest. So that C DAI that I got in the beginning will now be worth more than 10 DAI. So the kind of exchange rate of shares to underlying will change over time. And there's like a calculation of like the exchange rate that needs to happen every time there's a deposit or withdrawal. So that's what this preview deposit function is doing. It's doing that math to figure out how many shares do I get for this many inputs. And then it's going to mint that many shares. Well, it's going to take my assets and then it's going to mint me some shares to mint a deposit function. Mint is essentially kind of the same thing. It's just instead of specifying how many assets you want to deposit, you're saying how many shares you want to receive. It's just kind of flipping the math around. And then, of course, we can kind of reverse the whole thing and say, I want to withdraw. I want to redeem my shares and get the underlying assets back. So we have this withdrawal function, which will do the math, tell us, how many shares do I need to burn to withdraw this many assets. I'm not actually sure what this part of the code logic here does. I'll skip that for now.
Just to check, so if I'm withdrawing on behalf of someone else, if they've allowed for me to do so. I think.
Gotcha. Yeah, that makes sense. Yeah. So it's saying I can withdraw if someone's approved me, so I can transfer the tokens, but I could also like essentially burn the tokens. That makes sense. Cool, thanks. So yeah, then it burns these shares, and will transfer me the underlying assets. We've got this redeem, which again is kind of essentially the same logic again, but you specify the number of shares instead of how much you want. And then yeah, here's some of this like the math accounting logic. So like preview mint, preview withdraw. You're basically figuring out the exchange rate of shares to assets. So that's the 4626 vault standard. And then what I did was kind of made the same thing in Sway. But one way that it's a little bit, the Sway one's a little bit different is because every contract in Fuel and in Sway is capable of making like as many assets as it wants. There's no reason that our vault has to be like only accept one asset. So I made a vault that like
cool.
you can. Yeah, this is a vault where you can deposit any asset. And I was actually even thinking through. It was like you can deposit an asset, get a share, and then you could redeposit that share back into the vault. I don't know why you'd want to do it. You can just keep like stacking these shares on shares on shares. I don't know why you'd want to do it, but technically you could. And there's no like, as far as I can tell, there's no like logical like vulnerabilities that would let you steal anything that way. So here we have this deposit function, and because we're not dealing with like ERC20 tokens, these are like native assets. We mark this function as payable. So this looks kind of more like in Solidity you have payable functions. Those payable functions can just receive an asset. So in Solidity you have like message amount, message sender. Those basically the same thing as in Solidity, but in Solidity message amount will always be the amount of ETH that they sent you. In Fuel, we can say, what's the message asset ID? Like, what was the token that you sent me? And then from there, I didn't compile this code, so it might be sensitive. But overall, the logic follows. It's going to do the same thing. It's going to convert the amount of assets you sent into the number of shares. It's going to do I guess some of the math is here, but it's going to kind of update the balances of how much has been deposited, how much shares have we minted, and then it's going to mint some shares to the whoever is receiving it, and then it's going to emit this event. One little thing to notice about emitting events is that in Fuel, in Sway, you can just log any type of asset, any type of struct. Sorry, 1 second. Yeah, so in Fuel and Sway, you can mint any type of event. So here we're minting like a deposit event that's got like these assets and amounts. And we have like kind of the opposite logic here for withdrawing. So withdrawing, you would receive, again, I missed this table here. But for depositing, you would like send your LP token or your like vault token, and it would check that that's actually a vault token. That's kind of what we're doing by passing an underlying asset, and then burn that token and transfer back the underlying asset. So you can see here we're like burning the vault token and transferring the underlying asset. I think there's
That's really clean. That's cool.
I think there's a bug in the code here. This should be
the share asset.
This should be share ID. But yeah, overall it's like you said, like it's a little bit cleaner, a little bit simpler there. So, and you can see we're also this is how you would just transfer a token, because tokens are native. You just call transfer, and transferring a token, unlike in Ethereum, you don't need to worry about reentrancy. So in Ethereum, if you're transferring ETH, then that ETH transfer can call a function. So you got to be like, it's really hard to transfer ETH sometimes without like having these reentrancy vulnerabilities. But in Fuel, that's just not an issue because simple token transfers can't invoke code. So it's a little bit safer that way.
I see. So is it like an atomic action and no, not an atomic, but like is reentrancy then handled at the compiler level?
the compiler will give warnings, but some of it's just that like there's no some of this goes to the VM itself. So in the EVM, there's no like transfer ETH opcode. There's just a call opcode. So when I want to send ETH to an address, I have to like call that address as if it's a smart contract or whatever, and I'm just
Yes,
sending
with a
the call
value.
with a value exactly. And then if it's a smart contract, then like in Solidity you can have this like callback function that that runs when it receives ETH. In the Fuel virtual machine, there's like an opcode for transferring, which is different than the opcode for calling a function. They can actually both include assets. So like if I'm calling withdraw, I can include an asset in that call, but I can also just transfer an asset like without invoking anything. So that makes it a
Okay,
little bit safer there.
that's cool.
Yeah. And aside from it, you raised a good point. Like, reentrancy is still like, this removes this like accidental reentrancy vulnerability, which is kind of common, but reentrancy is still possible if you're calling contracts and you just didn't write you didn't follow like a check effect, check, or sorry,
Check effects interactions, yeah.
check effects interactions, exactly. If you didn't follow that pattern well, like you can still of course have this, but the compiler actually will give you a warning. Like it'll try to figure out,
Oh,
did you follow
cool.
that pattern, and give you a
Wow.
warning.
I wish
Yeah,
Solidity
so
did
that's,
that.
yeah, right. I mean, I guess there's like things like was it Slither is the
Yes, the checks for it, so you can run a static analyzer over, but it's a lot of extra work, and you've already written the code then.
yeah, exactly. So yeah, we tried to kind of like bake some of those things in there to just kind of catch these vulnerabilities
That's
in the
nice.
beginning.
And you, like you said, you're trying to lower the barrier to entry, so it's so good to have that.
Yeah, exactly. Like you want to make sure that like, yeah, it's hard enough to write good secure smart contracts that is, but you want to be able to focus on like, I guess for this vault type thing, it's like, okay, am I doing the math correctly of like converting shares between shares and underlying? Like that's your business logic. You don't want to have to worry about like, oh, I tried to send somebody ETH, and actually sending someone ETH is like kind of dangerous on the EVM.
Mm.
So cool. I guess that's kind of the end of the first part of like kind of just going over the way these assets work. I'll pause there if there's
Thank you.
any thoughts or
Super
questions from
interesting.
anyone. And then if not, I'll go on to the next part. But yeah, any thoughts or
I had
questions
a
here?
question.
Yeah, go ahead.
Where when you're writing to storage, it's the storage
Mhm.
of that specific contract at that
Yeah,
address, or is it the storage of? Okay, so it's the assets are stored in the wallets themselves, but
yeah,
or almost the mapping representation of the balances is stored in the contract.
yeah, exactly. So any
Okay.
like actual state, they're stored in the smart contract. So we're not going too far from the way like Ethereum works. Like your storage is part of the smart contract. I know like other things like Solana where you have like accounts everywhere. The storage can get quite complicated, but
Mhm.
if we kind of go back here, you can see like that would be kind of like the USDC supply. So this
Okay.
is the state, the supply of USDC is like a storage variable that's within this smart contract. But the funny thing is like the USDC smart contract can't really like, it's not even super aware of like what wallet the other tokens are in unless you kind
That's
of like
nice. There's a lot less
create,
bloat
yeah, a lot less bloat, a lot
per
less state
contract.
bloat. Yeah, exactly. And I've been kind of talking a lot about how like, this makes things simpler for developers, simpler for users. But one of the other main reasons that we structured it this way is this gives us like huge performance improvements because um, when we're executing the chain, when we're like executing transactions, um, we can parallelize kind of all these asset transfers. We can parallelize almost everything because it's
Oh,
kind of like it's like in the real world, right? Like if I hand somebody $20 and then like across the street someone's handing someone $5, like those two interactions don't have anything to do with each other. Like it's
I
not like
see.
they need to check me first. So
Mm.
if
So is that
Peter
because
is
you're using the unspent transaction output model, or is that for a different
uh,
reason? Is that because of the asset base as opposed to program base?
I'd say it's both. The UTXO makes it like I think the most performant and the easiest to parallelize, but you could imagine like um, even if we did an account model, but we put those accounts in Peter's wallet itself, like if we saved the state to Peter's wallet and and Sarah's wallet as well, then like if Peter was sending Sarah some tokens, like then just um, these two wallets would be dependent on each other, but like John and Uniswap would not be dependent on each other. The real bottleneck for trying to like parallelize the EVM would be like the trivial way to parallelize the EVM is you just look at what smart contracts are interacted with in any transaction and say like, okay, like, you know, if I'm transferring USDC and you're transferring DAI, those are separate smart contracts, so we can execute those in parallel. The problem is like a lot of people transfer USDC. Like there's only like a couple of assets that probably make up for like 90% of the tokens being transferred. So if you can parallelize different smart contracts, but every USDC smart contract, every USDC transaction is in serial, then like you're not even gonna get much benefit from that parallelization. And so
that makes a lot of sense.
So by having this asset-oriented model, and especially by using UTXOs, we can get a ton of performance there. And
that's awesome. That's so exciting.
Yeah, I'm super excited about that. Cool. Any other thoughts or comments here, or should I get on to the next part?
I think you can continue. Thanks.
Yeah, I think so.
Awesome. So that was kind of like the basics of like, you know, how assets work on Fuel. There's this other kind of really interesting feature of Fuel called predicates, which kind of ties into this asset-oriented thing. I'll say it's something that is it's something that doesn't really exist on many other blockchains, although I'll talk about that a bit, but it unlocks some really interesting functionality. So I'll just try to explain what the heck are predicates. I originally actually made this presentation talking to people at Fuel because, you know, even I felt like internally, like a lot of people on our team didn't have a real grasp on it because it's a bit different. I was saying that, you know, predicates, they are unique to Fuel, but they're not 100% unique. They actually have a base in, get to it in a second, but they're basically inspired by Bitcoin. I kind of went back to base principles of like what does ownership mean? In the real world, ownership means like possession. Do you have some object? Are you holding it? Can I control like who gets this asset? Ownership doesn't really make as much sense in the digital world because information is infinitely copyable. So like everyone has everything in some sense. Everybody has the entire Bitcoin blockchain, the entire Ethereum blockchain. So in the digital world, ownership is more like, do you have the permission to move that asset? Here we go. The ability to move an asset on chain. This is what blockchains essentially do, is they're a system where everybody has the state, everybody can see everything, but there's a set of rules about can you move an asset. And if you have the ability to move an asset, then you're essentially the owner of it. So in Bitcoin, you know, you have some Bitcoin, you own that Bitcoin because I can move that Bitcoin to the next place, and I move that by cryptographically signing a message. That's how Bitcoin works. But what if instead of like kind of having the rules be set by the chain of like the rules are you need to sign a message with a private key, what if we can make our own rules? So Bitcoin added this feature called pay to script hash. I think I got that acronym wrong here. It's P2SH. And what this does is it lets you, instead of like sending Bitcoin to somebody's public key, you can send it to essentially a piece of code on chain. Not actually the code, but like a hash of the code. And then to be able to like spend that Bitcoin to send it to somebody else, you have to both first like share that code. You got to be like, okay, this is the code that you hash to get this address, and then the code needs to like execute correctly. Skip that part. And so this lets you like build really simple, like some Bitcoiners will say like, oh, you can build smart contracts on Bitcoin. You can build very primitive smart contracts on Bitcoin with this functionality. So what we have here is like, this is how multi-sigs work on Bitcoin. We're basically saying like, it's not really readable at all, but there's some public keys. If there are signatures that match these public keys, then basically the transaction is valid. 2 out of the 3 people signed it, you can send it to Bitcoin. Here was a more complicated like time lock where it's like, we're checking like, did the block time, like has a certain amount of time passed. So it's like if a certain amount of time has passed, then maybe somebody can like take their Bitcoin back. Otherwise, somebody else can take the Bitcoin. can't. It's so hard to read. Like I can't really read that. But this is kind of how you build like primitive logic on Bitcoin. Uh, this is like, if you think about it, this is like really interesting because you have assets owned by code. They're not owned by a person. They're not even just owned by like cryptography. They're owned by like programming languages, like human written code. Um, and then if we kind of go to what Ethereum did, is Ethereum took this idea of like code that can own assets, and it added all these big features we were talking about. It's got a VM. It's got the code is stored on chain, not just a hash of the code, and it's got this like arbitrary storage. You can store all like arbitrary types of data and do arbitrary computation on it, which means we can build much more interesting things than you can build with Bitcoin, right? You can build DeFi, you can build social recovery, like account abstraction, you can build rollups, you can build blockchains that are validated by other blockchains. The problem is like, this is amazing, but it can become very expensive to do simple things. So doing things like making a multi-sig wallet or a social recovery wallet can get really expensive because you have to deploy like a whole smart contract. So now we'll go to fuel stand or fuel stand, as I wanted to call it. So a lot of what we like inspired Fuel was taking some of these principles from Bitcoin and the expressibility, the endless like things you can build with blockchains and Ethereum, and combining those together. And so predicates are just taking this like P2SH that Bitcoin has, but the expressivity of Ethereum, being able to write like Turing complete code in like a modern programming language. If we combine those two things, we have predicates. So a predicate, it's an address, but there's like some code that backs that address, which conditions when can I spend these coins. The simplest, like the very simplest predicate I could make would be like an address to just give away coins. So imagine you just like, I've got a bunch of coins, I just want to give them away for free. It's actually like not super trivial to do that on Ethereum. You could like give away your private key, but maybe you don't want to give away like a private key. You just want to give away like a certain amount of tokens. You could make a smart contract to do this, but again, that would work. It's just kind of overkill. To have a predicate, you make some code that says like, when is this, basically what transaction is valid? Well, the transaction is valid if it just returns true. So any transaction that uses this predicate, it's always valid.
I see. So I can take as much as I want to.
You can take as much as you want from this predicate. Yeah. The funny thing is like this, somebody will make like start sending coins to this predicate, like, and because it's the predicate address is a hash, like Fuel will have some address like this where people will maybe just, it's like the cup at like a gas station, you know, like take a penny, leave a penny, maybe.
Or maybe for airdrops, it's nice because you don't have to whitelist addresses. Everyone can just come to this, and if it has enough coins still left, you can take as much as you want. I mean,
I guess I'd say
that doesn't stop one person taking everything in the first transaction.
I think that's the problem. if it's worth anything, someone's just going to scoop it up. But there are some ways you can do like some interesting airdrop type things with predicates, but might be a little more complicated than this. But I'm curious. I'm sure someone will find something cool to do with this. Here's like a slightly more complicated one, which is like, okay, a password protected token where you write some code, you pass in a string, and it's going to hash that string. And if it matches a hash, then you can take the tokens. This would only kind of work. You would only want to use this like once, because as soon as someone sends the first transaction, they basically have to provide the input, and now anybody can like do the same transaction later. But if you just want to give away coins one time with a password, that's a simple predicate you could do. But there's some actually like more interesting stuff we can do. And so I actually like I put this code into my editor so you can look at it more fully. Is you can have these predicates be act as wallets, but they can be wallets for different kinds of signature schemes. So in Fuel, like by default, Fuel uses a different type of cryptographic curve than Ethereum does. So like a default Fuel wallet is a different address, a different cryptography than Ethereum. But we also, we're part of the Ethereum ecosystem. We want to support MetaMask. We want to support all the Ethereum wallets. So what we've made is a predicate that basically uses the Ethereum signature recovery. And if you can kind of recover a signature that signs a transaction, then your transaction is valid. So boom, now Fuel supports MetaMask. And you can do this for basically any kind of cryptography, any cryptographic curve. So I think someone on our team built one of these for Bitcoin. I don't know how that would work in practice, like a Bitcoin wallet that can send and receive Fuel transactions, but cryptographically we can support that.
Wow, that's really cool.
Yeah, you can support Solana, you can support Cosmos, any type of wallet. We can support it, and in some ways this is lets us be really unopinionated and say however cryptography evolves, we're not locked into one type of cryptography. People are even doing, I don't know if you've seen some projects are looking at the I forget the technical name, but there's an API for the fingerprint scanner on your your laptop or the face scanner on your iPhone, where you can basically sign messages with the hardware secure enclosure. There's a number of projects that are trying to this is amazing user experiences if people can sign a transaction with their fingerprint or their face.
Or any wallet that they want.
Yeah, with anything. So we can support send a
and any
transaction
cryptography yet to be imagined. That's so cool.
Exactly.
That's
Yeah.
modularity, I suppose.
Cool.
Yeah. So,
we had a question. If you could please just elaborate on the difference between predicates and smart contracts themselves.
That's a great question. I think, we tend to think of predicates as these kind of really confusing magical things, but a predicate's essentially a stateless, it's like a smart contract, but it's stateless. So if, the whole storage block that
it's just pure code.
That's the way. Yeah, so there's no storage. You can't update the balance of something it's immutable. The code is not stored on chain. So a smart contract, the actual code is stored on the blockchain. For a predicate, just like the Bitcoin P2SH, the code is only a hash of the code is put on chain. So every time you send a transaction, you have to reveal the code. Yeah, I'd say that's the main difference. It can do kind of any arbitrary logic. But it's essentially a way of permissioning these asset transfers.
Wow, very cool.
So yeah, things we can do with predicates is we can support any kind of wallets. Yeah, I guess this kind of answers what we were just talking about. So predicates are stateless. They can't. This is another difference is not only can they not store state, they can't access state of other smart contracts. So you can't read the balance of something. You can't check the date, the block number. Some of this is a performance thing. It's that predicates, one difference is predicates can be much, much cheaper. In some ways because they don't have any state, but also because by not accessing the state, it means once a predicate's evaluated to true, it's always true, given the input to it.
Oh, I see. Also because it's a hash of the code, and then once you execute the code, it's no longer the code is visible, so it'll evaluate the true. Or is that a different thing?
That's part of it, but it's also the stateless part. So you can imagine if I'm trading on Uniswap, I could make a trade, I sign a transaction to make a trade on Uniswap, and it's okay, that transaction's valid. But then in the time between I made that transaction and when it gets included, maybe there's a really big trade and the price changes, and now my slippage, it's gone out of bounds. So now my transaction, which was valid before, it's going to fail because the state chain. And since predicates can't access state,
always
once
true. I see.
If it's true, yeah. If it's true, it's always true.
No matter what happens around it.
Yeah,
That's
given the input. But the things it does have access to is the input coins of a transaction. It can basically see everything about the transaction. It can't see the state of the chain, but it can say what coins are being sent, what coins are being outputted. It can even see kind of the script. This is kind of the other things that are happening in a transaction. So it can still do some interesting stuff. I'm not going to kind of go. I'll skip over some of these slides because I just want to show a little bit of some of this code here of other predicates and other things we can do. Here's a predicate for an atomic swap. So I was talking before about an order book exchange on Fuel. The order book exchange project they're building it with predicates. the idea being, order books, you don't want to have to like write a lot of state to the chain every time. Like order books, they're creating and closing trades all the time. So if you have to update a smart contract a lot, that gets really expensive. Instead, you can have a predicate that the predicate just kind of says like, okay, I want to like, what is it? Ask this. Working on. Okay, I think this ask token. I'm missing something here, but it's saying essentially I want to trade one token for another token, and okay, this is ask. So this is saying what I want to receive. You're saying I want to receive like 42 of this token. So if you give me 42 of that token, you can take all the tokens I own, which it's essentially this is the send and the receive. So if you send 42 tokens of this type of token to this address, then your transaction is valid. And the logic we have here, it's basically going to check those conditions. There's also a bit of logic that like the creator can cancel their transaction. So if they want to cancel their trade, they can revert it. So we have a full like an order book, just like on an order book exchange. But again, like none of this code is actually stored on chain. It's just like a hash of this code is stored on chain. So it makes it really like lightweight and very cheap to do something like this, which you can't really do with smart contracts.
Wow, that's awesome.
Yeah, and again, this comes from a project that's being built, so I'm excited to see that one. The one other example of predicates I have, and I know we're getting to time, so I'll kind of like wrap up with this one. This was one I made, and just a cool idea I had of like what is like one problem that like kind of very like simple problem people have with blockchains is, or just crypto more generally, is people want to send tokens to someone and it's really scary. You're going to send tokens and you're worried to like copy the address wrong, right? You're like, I really hope I got this right, because if I copy pasted wrong, if you send a test transaction, because if I sent this wrong, then it's just getting stuck forever. So one thing we could do with the predicate is make a really simple predicate where there's like a sender and a receiver, and you can kind of send any tokens to it, and I call this like a pending transfer. Eventually send tokens to the predicate. You have some mechanism like alerting that other wallet, like there's a pending transfer, and then that other person can like complete the transfer. They can hold
if it's a
the tokens into
valid
their wallet.
address.
Yeah, but
Right.
if you typed it in wrong, or maybe you change your mind before the other person receives the transaction.
Maybe suddenly they were mean and you're like, no, never mind. You don't get your allowance this weekend.
I'm canceling my transaction. Exactly. So then, the sender can just take those coins right back. So this is just an example of like the arbitrary logic you can put.
In Solidity, there's an OpenZeppelin library called Ownable Two-Step. And if you put in the new owner address wrong, it doesn't matter, because the ownership is only transferred when the new owner accepts the transfer of ownership. That's really cool.
Exactly. Yeah, and that's super smart. But yeah, I'd say like for that thing in Solidity, it's like, I mean, it makes it a little more expensive. Probably not that big of an issue, because it's like you don't transfer
Whereas
ownership.
With the predicate, it's so lightweight. Wow.
Yeah, so this is super lightweight. This is basically like slightly more expensive than a normal transfer. But when I like came up with this idea, I was like, man, I would love to see this in a wallet. That'd be like really cool to be like, yeah, you have these pending transfers. Like, do you want to confirm those, or do you want to like ignore it? I guess
that's very cool.
Yeah.
Maybe while we're actually talking about predicates, Fuel has a grant application out this quarter, and they are encouraging applicants to submit project ideas that leverage Fuel's technology stack, so specifically predicates and their multiple native asset support. I think applications close on Monday, the 11th of September.
They do,
so
yeah.
That's coming up. But if you have a cool idea for a project to build on Fuel's ecosystem, this is a great opportunity.
Yeah, absolutely. Any project that like thinks they could leverage these features would be great to have them on Fuel. If you have any like thoughts or questions on again any of this stuff, but especially predicates, feel free to reach out. I guess, and always happy to chat about these.
Thanks, that's cool. I'm actually considering applying for the grant.
Amazing.
Yeah, working on an application today.
Amazing.
Oh, that's pretty cool.
So thanks, this was very helpful.
Yeah, are there any, I can finalize the screen share. Are there any other questions from any of the viewers or Tam, anyone? Well, we will post we will post the video will be available on YouTube under the live stream, but we're working on trying to translate the live stream into an actual video. If we can't figure that out, because we haven't been able to figure it out, we'll just repost it. We'll repost the video and it will just come up on the newsfeed, and you guys can share that video and do everything. But if anyone has any idea how to do that, that would be very, very insightful. But anyway, yeah, thanks guys. Thanks, David. That was super, super cool. It was a very beginner friendly as well, like walkthrough. So thank you for that. I think we all learned a lot. And yeah, I think
thanks so much for having me. It was a lot of fun.
Yeah, I think that caps this episode. And Fuel will be next week in Token 2049, right?
Yeah, that's right. I'm in Bali right now.
Oh,
about
awesome.
to hop over to I wanted to kind of get over the jet lag before the conference started. So if anybody's in Singapore and wants to meet up,
nice.
yeah, let me know.
Yeah, so I will be there, and the Web3 Sanctuary team will be there, and Linum Labs will also be there. So yeah, if anyone's interested in I don't know, planning a meeting or anything, just like chatting, with just DM us on Solidity Fridays, and we can make it happen as well.
Awesome. Yeah, would love to meet up.
Yeah. Amazing. Yeah, cool guys. Thank you. Cool. Catch you guys next week.
Thanks. Bye.
Take care.